Hello again, Algebra 2. So we're entering into Chapter 3, which is all about solving quadratics, which means you have to know how to factor, complete the square, use the quadratic formula. That's going to be the focus of the chapter. So back in Algebra 1, I realized that was a long time ago. You guys did a lot of factoring, and this is meant to kind of review what you learned back then. So let's start off with the first step. First thing you always want to look for is looking for what we call the GCF, the greatest common factor, because that will make your factoring easier and your solving easier. So notice in the example, when we look at these two terms, they both have 3 and x in common. So what's really happening here, when you are factoring something out, you figure out what that common factor is, and then it's as if you divided each term by that common factor. That is what goes in the parentheses. So we had a plus, that becomes a plus. Here the x is completely canceled and you have the 4. So that's how we got that example. The idea behind this then is I would set it equal to 0, set each factor equal to 0, and we could solve. So this next one, if you want to go ahead and try it, you can always pause and try these on your own, which would be the preferred way to do this, but since it's a video, I will keep going. On the future examples, feel free to stop the video, try it on your own, and then watch as we do it. So, all these terms, they don't all have an x, so I can't pull an x out of everything. They are all even numbers, and they are even more than even, they're all divisible by 4. So the common factor that's going to come out is the 4, and if I were to divide each term by 4, I'd be left with 3x squared plus 2x plus 1, and that would be as factored as you could get for that particular problem. Now we get into the fun stuff. So ax squared plus bx plus c, taking a quadratic in standard form. Of course, we're going to start off easy and keep that a as 1. So we've all learned different methods. Guess and check is totally a valid way to do this. I'm going to show you one method. If you know how to do it a different way, by all means, it's not about the method, it's about getting to the right answer. So when I am factoring, the first thing I do is I look at my numbers here, a, b, and c. A times c is going to go on top, b is going to go on bottom, because the idea is we want to unfoil this. That's what we're really doing. And the way this works is the first terms, these, you remember when we were unfoiling. So the first terms are what give you a. So in this case, or ax squared, the first term. So this one's easy when a is 1. You know that'll be x and x. That's the only way to get x squared. The last term, however, is going to be a combination because it's the product of a times c, which in this case is just 8 when a is 1, and what do we multiply? Because when I multiply those last terms, that has to give me 8, but those two numbers have to add up to 6. So in this case, we're going to have a positive 4 and a positive 2, and that is how we would factor that. And you can see that 4 times 2 gives you the last term, 4 plus 2 gives you 6, so that's factored. If you have negatives involved, it's still the same process. So a times c is going to be a negative 45. That's our a times c, the first and the last term. Middle term is going to be a negative 12. And so we know, because the first term is x squared, the only way to get that is x times x. How can you get a negative 45? Well, we look at factors of 45. We have 5 and 9. That doesn't add up to 12. I could try 3 and 15. So I'm looking at 3 and 15. If I add or subtract them, are 12 apart. So I want to have a negative 12 for my sum. So the larger number here is going to be negative. So it's going to be x plus 3, x minus 15. So that gives me a sum of negative 12, and it gives me product of negative 45. So now if you want to go ahead and try the one here, then pause the video, and I'm going to keep going here. So we're going to make our little x, positive 18 will go here, a negative 11 goes here, and whenever your last term is positive, that means, especially if the sum was negative, that means both of these have to be negative together. So factors of 18 are 9 and 2. That would give me, if I added those, a positive 11. But if I make them both negative, the product is a positive 18. The sum is a negative 11. So this will become x and x. That's the only way you can get x squared. Minus 9 minus 2. That's what goes in the parentheses. All right? Now, that's very Algebra 1. Those are not the ones we're going to be focusing on because this is Algebra 2. The ones we're going to be focusing on is when a is not 1. And there are several ways you can do this. There's a longer way that definitely works every single time, or there's a shortcut that I like to do. And if you're good at noticing patterns, some people like it. Some people prefer just to do the guaranteed longer way. So let's look at how this works. You start off the same way. We know that it's going to be a times c on top and the middle term on the bottom. So in this case, though, the a times c is not going to be just the last term because you have a different a value now. So 4 times a negative 12, negative 48. Middle term is negative 13. We still want to figure out what times what. When you multiply 48, will add up to 13. So we're going to look at some factors of this. Let's see, we know that 4 times 12, but that won't give me 13. I know 3 and 16 multiply to give me 48. And if I made my 16 negative, that would work. So this is going to be a 3 and a negative 16. So these are the numbers I know that add up to a negative 13. So what we're going to do is called factor by grouping. We're going to rewrite this equation, but we're going to expand the negative 13. I'm going to put a negative 16x here plus 3x. Those are those terms we got from the middle here, 3 and negative 16 minus 12. Now the reason I rearranged the order is because I know that 16 is now paired with 4, because what I'm going to do now is factor each 2 terms individually. So from the first 2 terms, I'm going to pull out 4x, and that's going to leave me with x minus 4. And then the next one, I'm going to pull out a positive 3, and that's going to leave me with an x minus 4. You know you did it right if these two, what's in the parentheses, are both identical, because now we're ready to factor this. So we have a common factor of x minus 4, and what is outside the parentheses here, the 4x and the plus 3, that's what goes together in the second parenthesis. And we have now factored 4x squared minus 13x minus 12. All right, let's try this again. So we have 6x squared plus 13x plus 6. If you want to try that on your own, pause the video right now. But I'm going to continue on. So remember, what goes on top is the product of a times c. So that's going to be a positive 36. Down here is 13. So 36 factors of 36, both a positive 9 and a positive 4. That'll add up to 13. Now remember, those are not what goes in the parentheses. These are what we use to rewrite the middle term. So we rewrite this, 6x squared plus, doesn't really matter which one you use. I'm going to use the 9x plus 4x because that adds up to 13x, then plus 6. So then what we're going to be doing is factoring the first two terms and factor the next two. So from the first two, I have a common factor of 3x. That's going to leave me with 2x plus 3, because if I divide each of these by 3x, you can then see how we got that. And then the next one, I'm going to take out plus 2 from each of these. So that's going to leave me with 2x plus 3. And notice once again, we got that common factor. So we pull it out, 2x plus 3 from each of those. And we put together what's sitting out in front, 3x plus 2. And now that's factored. That's called the factor by grouping method. And it always works. Now, I'm going to show you a little shortcut to doing this. And again, you can totally ignore this if you don't like it and it just seems too conceptual, but some people, it kind of makes sense. So we start off the same way. So we're going to do the a times c, so that was our negative 48. Negative 13 goes down here. From the example we did before, we know that this is going to be a 16 times a negative 3. That adds up to negative, whoops, no it doesn't. Negative 16 and a positive 3. There we go. Okay, that adds up to a negative 13, multiplies to a negative 48. Okay, so what are we doing here? It's like, I noticed that 4 goes into 16. So I am going to do my two parentheses here. Now there's several ways to get 4x squared. It could be 4x and x, or it could be 2x and 2x. However, only one of those two numbers is even, so I'm going to do 4x and x and what I call the double rainbow. What goes on the double rainbow are these two numbers. So negative 16, I'm going to write it on the rainbow coming out of the 4 because 4 goes into 16. The other number, positive 3, is going to go here. And you're going to ask yourself, 4 times what is a negative 16? Well, that's a negative 4. And here you're going to ask yourself, 1 times what is a positive 3? And there we go. So notice we got exactly the same answer we did as in that first example. Those are the same example. It's a little bit shorter, but it's a little more conceptual with the whole. What we're doing here is when you FOIL, the OI in FOIL, that's your outer and inner, that's what creates the middle term. So that's what we're doing here. This is our outer and our inner, that's your OI. Okay? I'm going to try this last one. If you want to try it on your own, you can pause the video. So we have our diamond here. 4 times 4, a times c is 16. This will be a negative 17. So this is going to be a negative 16 and a negative 1. That adds up to a negative 17. But negative 16 times a negative 1, positive 16. All right, so once again, I notice only one of these terms is even, so I'm going to stick with 4x here and x here. If both numbers had been even, I would have done 2x and 2x for my 4. So the first term gives me 4x squared. Now I put on my double rainbow, and the number that 4 goes into, negative 16, that goes on this rainbow. The other number, negative 1, goes here. And you ask yourself, 4 times what is a negative 16? 1 times what is a negative 1? And that is factored, x minus 4. Okay, so we have a few more strategies. These last ones, well, this first one I definitely use a lot, the difference of squares. The second one, the perfect square, I hardly ever use it. I just factor it using my other methods and then usually notice, oh wow, I have a perfect square, but we'll look at that. All right, so a difference of squares is, difference means subtraction, and we have two squares. Notice there's no middle term. There's not three terms, it's just a squared minus b squared. What happened when you FOILed was that you added and subtracted away the middle term. So here's your OI in FOIL. So you have AB times a negative AB. That's why you have no term, no middle term. So when you're looking to factor a perfect square, so I notice here our first example, 4x squared minus 9. What you're doing is taking the square root of the first term, so that's going to be 2x, the square root of the last term, which is 3, so 2x, 3, and because there's no middle term, that means you added and subtracted it away. So that's what you're doing when you're factoring a difference of squares. All right, so if you remember that, go ahead and try this next one. I'm going to go ahead and just keep the video going. So I'm going to put up my parentheses. Square root of the first term is going to be 5x. Square root of the second term is 7y. And then there's no middle term, so we put in a plus and a minus, and you're done. Okay, our last strategy, and again, I don't use this one that often unless you actually notice what's happening. Sometimes I will use this if I notice the first and the last term happen to be perfect squares, and their square root, the product of them got doubled. But I don't always notice that. So, for instance, here we have 4x squared plus 36x plus 81. So I notice there's a perfect square here and here. So what I try is, oh, what if I did 2x and 9? So I took the square root of the first and the last. Everything is positive. Would that give me a middle term of 36? Well, you do your OI. That's 18 and 18. And 2 times 18 is 36. So we usually write it then in condensed form because it's the same factor squared. That's why we call it a perfect square. So let's try this. And again, pause if you want to try that one on your own. So we notice perfect square, perfect square. So I'm going to take the square root of the first term and the square root of the last term. And in this case, I notice that my middle term is negative. So that means these have to both be negative, so I'll get a positive product for the 25. And let's do our OI. So a negative 15 plus a negative 15 is in fact negative 30. So this will factor into 3x minus 5 squared. Okay? Those are the notes. And I'm going to kind of leave it there for now, and then just put up an answer key because you guys are now going to do the rest of this.